Just drives me crazy.
The Charlotte Mason education belief that if it's not in the Ambleside online list, it's horrible and rots your brain.
Funny thing is I don't know that Charlotte Mason even really believes that exactly. I have come more and more around. You know, I went through a long phase of like being pretty anti-classical education in a lot of ways, but I've come around to be more and more appreciative and thinking that classical education makes a ton of sense and has lots of intrinsic value, and it answers a lot of the questions where people are like, oh my gosh, when am I going to use this in your life? Well, are you going to use your brain in your life? Because that's what we're trying to help.
That's the point. Yeah. I have found, as my mother has educated all of my various younger siblings, how very
Well, and there's a lot of puzzle pieces in there, right? Like some stuff. There are some, but it's less about how, like, are you going to thrive in Algebra 2? No or yes, because you're already naturally good at that type of thinking. Is it still good for everyone? Yes. And so that's the thing that I've kind of really come around to, is that just because you're not good at math or good at English doesn't mean that practicing that type of thinking isn't good for you.
No, for sure.
And that's where we get confused.
Yeah. It's just the process of trying to do it in a way that is going to be good for whatever.
Yeah.
Because you don't want them to hate math. You don't want them to
No.
because you do it in a way that's not good for them.
And teaching them to appreciate the value of the thing is useful, which is something that we forget to do in our society. Most societies. We've totally lost the plot when it comes to education. We don't know what that means at all. This was number 9. This was asked about, yes? So when we subtract off the 8, we end up with the absolute value of b minus 3 equals negative 5. When, dear children, will an absolute value ever give a negative answer? Never. So therefore we stop right there and we say no solution and we move on with our lives.
Okay. Is this on a homework set or a quiz?
This is all the quiz that you missed.
So that's what I did wrong. Gotcha. Okay. Understand.
All right, let's go to today's stuffs.
On some of those problems, on last homework, the answers were negative, but they were still
On which?
on the last topics that we did last week.
So B in this, like, so let's pretend like this was this. B could be negative. The absolute value can't equal a negative. Like the variable could turn out to be a negative. There's nothing wrong with that. Because see, like let's make up one that would work that way. So like, let's say x minus 3 equals 5. Right? We split those into two things. X minus 3 equals 5. X minus 3 equals negative 5. Right? X equals 8 and x equals negative 8. And then let's plug the negative 8 back up in here, yeah? So negative 8, wait. This one is, that's not true. What am I doing? How about negative 2? Let's plug the negative 2 up here. Negative 2 minus 3, absolute value. What is negative 2 minus 3?
Negative 5.
Negative 5. What's the absolute value of negative 5? 5. So the variable can get a negative answer on the inside. It just, the whole absolute value won't ever equal a negative. Does that make sense, the difference? Good. Good. It's a great question. All right, let's look at today's stuff. Yes.
On 1-6. On 5-1-6, is that what we were doing today, correct?
Was that what was due today?
I believe so, yes.
Well, then, yes. Okay. In case we didn't notice for some reason, because we're not paying attention, we have a test Thursday. So, you know, if you haven't started studying yet, you know, start soon. What do we do? Like 10 through 40, 2 through 40? 2 through 36, evens. Number 2, I'm going to describe these pictures out loud. If we need to come back and like draw any of them, whatever, that's fine. Not a problem, but it's going to be faster than putting it up on the screen. And since it's 2D, I think we got this. All right, so the number 2 is D less than 20. And the graph would be an open circle shaded to the left. Number 4 is Y is less than or equal to 7. And the picture is a closed circle shaded to the left. Number 6, Z is greater than or equal to negative 3/4. It's a closed circle shaded to the right. Number 8, X is greater than or equal to negative 8.5, and it is a closed circle shaded to the right. Number 10 is M is greater than negative 4, open circle shaded to the right. 12 is R less than negative 6, open circle shaded to the left. 14, W is greater than or equal to 28, and it is a closed circle shaded to the right. 16, X less than 9, closed circle shaded to the left. 8, yes. 18 is Z is less than or equal to 3.9, is a closed circle shaded to the left. 20 is Y is greater than 8/3. It's a open circle shaded to the right. Arguably, that answer, since we're having to graph it, would be better as a mixed number, which would be 2 and 2/3. Number 28 is X is greater than 2, open circle shaded to the right. And 30 is N less than or equal to 32, closed circle shaded to the left. 32, X is less than or equal to 8. It's a closed circle shaded to the left. 34 is invisible. There it is. N greater than negative 15/11. Again, it'd be better as negative 1 and 4/11. Open circle shaded to the right. 36 is Z less than or equal to 26 and is a closed circle shaded to the left. What questions do we have? Sure. Oh, I didn't read part of the answer on 24 or 26. Number 24, the quotient of 3 times a number and 4 is at least negative 16. And we're supposed to define a variable, write an inequality, and solve the problem. I'm going to use S for Sean. Great. The quotient of 3 times a number and 4. So what does quotient mean? Division. Now, we're looking for something in particular to figure out where the division symbol, or fraction bar is a better way to write it, but where that is going to be. What are we looking for to figure out where that's going to be? The and. It's the quotient of this and that. So the quotient of 3 times a number and 4 is at least negative 16. So where are we going to write for that? Oh, you'd think so, but no. Greater than or equal to. Now let's put a pause in that. Because this has got to be at least this. So this has got to be bigger than negative 16, which is kind of the opposite of the way we might think, because we think least, whatever is at least, and then we put the less than symbol. That seems to make sense. But stop and think for a minute. It's got to be at least that, so it's got to be bigger than that, right? And then we solve the thing. We multiply times 4 on both sides. We end up with 3s greater than or equal to negative, was that 256, is that right? Or 128?
64, right?
Oh yeah, not times. I'm doing like powers. Sorry, yes, it is 64. Now what? Divide by 3. And get s is greater than or equal to negative something. Negative what? 21 and a third. And then we draw our number line with a straight edge. And then we put a 0 over here for relative positioning, and then we put negative 21 and negative 21, then we put negative 22, and then we put our little closed circle about there and go.
Can I quote you on that?
What?
Can I quote you on that?
Yes. Your graphs need to be at least that good. If they're not at least that good, then I'm going to count off. I don't understand why you have your computer. I don't get it. Because you have your notes and all the thing and homework on paper, right? So why is the computer?
I have no idea.
Okay, we'll put it up because you don't need it.
It just is.
Well, what if we make it better than that one?
Make it better than that is great. However, the one that I don't like, the one that I don't like that people do, that I find to be annoying, is when we do this, and then your graph is this. I don't like that. That's stupid, especially since there's no circle on it. Just do it the way I told you. Don't be like, but it's so much neater. Okay, if you want to upgrade and go the neat route, then get your little ruler and go like this. And then put your little circle and then go, right? Okay? If you need the neatness, still like follow the rules.
We are anti-minimalism in this establishment.
It depends on what we're talking about.
Get it out.
Usually in math, like that's our goal, is minimalism, is to minimalist it as far as we can, actually. But all right, any other questions from this lesson? $36. Sure. None of our answers had no solution. I guess it makes sense because they're not compound yet, but. $36. How many are there? There were 36 last year. 37 last year. You had to have been. Oh, Dudley. So those of you who like Harry Potter, or even meh Harry Potter, what are your predictions about the TV show? You think it's going to be good or bad or somewhere in between?
I think it's going to be about the same as the Percy Jackson.
The show?
Yeah, the remake, yeah.
So you think it's going to be better than the movies? Because the Percy Jackson show was definitely better than the movies, because the movies were very bad.
I like the movies.
Wow. You know, this is not the hottest take I've ever heard, and we're going to do this math. Okay, say your little piece. Go make it fast.
With the Percy Jackson series, apparently the person who wrote the book was on set and was a director.
Yeah, for the show. Yeah. So the hottest, like, multimedia take I have ever had, and I still kind of question this child's sanity, was he said, in his opinion, that Russell Crowe did a better job as Javert than Hugh Jackman did as Jean Valjean. And I don't think that child is sane. That doesn't, that's like the hottest hot take I have ever heard. What?
Child said that.
Nate said that.
Oh my. He is very confused. He is very, very wrong.
That's like a very strange take.
I don't
Okay.
even love Hugh Jackman as Jean Valjean, but like that's still wrong.
Yeah. I think he did a great as a film.
Yeah.
In the film. That's a big, people that are diehard like Broadway people are like, oh my gosh, he did such a, no, he didn't. He did amazing for a film version. Because you have to do the numbers different in a film version. On stage, the camera isn't here. You do that different than if we're belting songs across the room. What should we do to solve this monstrosity?
Multiply by 4, both sides.
So we should, or both, kind of, right? Your goal, what you're saying, is get rid of the fractions, right? Because they're ugly. We don't like those. Not right now, anyway. We might deal with them later. But we need to get rid of them. So how do we get rid of them? We're going to do this a lot. This idea a lot in this class. So if this is the first time you've ever seen something like this, you may want to make sure you write it down, take a note. Make sure you understand what's happening. But we're going to get rid of the fractions by multiplying everything by the least common denominator. What is the least common denominator between 5 and 4? 20. We multiply this one times 20, 5 cancels out, leaving us with just 4, right? Mm-hmm. So on this side, we're going to multiply everything by 4. Because 5 goes into 20 4 times is left, 5 on the denominators cancels out, right? Denominator gone away. On this one, 4 goes into 25 times, so we're going to multiply everything times 5. Okay, now we've got something that's easy to handle. What can we do with this? Distribute it. What is 4 times 9z?
37Z.
No, it's not.
No, it's not. You're wrong. It's okay, 36Z. It's fine. We're fine.
I thought you were doing a bit for a second.
I was not. It would have been funny. I mean, it wouldn't have been funny, but it would have been better.
4 times negative 4.
Negative 16.
Negative 16. What's 5 times 7z? 35z. 37z.
Exactly.
See, it can be a bit if I make it.
Could be a bit if you make it a bit. All right, now what?
Subtract 35 over sides.
Just 35?
And add 16.
Just 35?
35z.
Oh, 35z. Yeah, we can also go ahead and add 16. Yes, for good measure. So we end up with z less than or equal to 26. Get our handy smandy ruler. Put our line on there. Put a 0 on there for directionality. Put a line on there. Label it 26 because I said so. 26 what? I don't know. Doesn't tell me anything about no stinking units.
This is just going to be on the video.
What?
Talking about Broadway.
Yeah, it is. It's going to be on the internet forever. If you go back and watch some of my lives, you never know what might happen. There's all kinds of takes about all kinds of things. Politics, Broadway, books, movies, TV show, colors. You never know. Some of it might be entertaining. I'm going to throw something out there. We do this with a closed circle. If you want to have one more, if you want to be a contrarian and you want to do it different because you want to be different, there is another way to do it. This is technically the way you do it in interval notation. Some of you probably will see this in college if you take college algebra. They often do it this way in college. You could do a square bracket for equal to, and then do your shading. What would be not equal to?
Circle? How many square filled in?
A round bracket, or we call it a parentheses as well. Round bracket is not wrong. We just don't usually call it that. Yeah, so you could do it that way if you want to be a contrarian. And I won't count it wrong. Although technically you wouldn't use it with this notation, but it's fine. Let's do the next lesson, shall we? Compound and absolute value inequalities. Did we do 2 through 30? 2 through 40. Let's see what those look like. Probably because word problems. Oh, yeah, that's why. It's because word problems. Okay. All right. Number 2 is negative 1.5 less than or equal to y less than or equal to 4. And we got 2 closed circles on each side shaded in between them. Number 4 is, so you technically have to use or notation on this one because they're shaded on the outside. All right, so it would be m greater than or equal to 4 or m less than or equal to negative 5. And you've got closed circles, like I said, shaded to the outsides. Number 6 is all real numbers, and it is shaded everywhere. Number 8 is the null set, and it is just an empty, blank, sad little number line with nothing shaded on it anywhere. Tears. Number 10 is negative 1 less than or equal to t is less than or equal to 2.5, and it's closed circle shaded between them. Number 12 is in the answer appendix, so let me turn the page. Number 12 is 6 less than v less than 10, and it's got open circles shaded between them. 14 is r less than negative 9/4 or r greater than 3, and it's open circles shaded on the outside. 16 is negative 2 less than h less than 2, open circles shaded in between. 18 is x greater than 14/3 or x less than negative 2, and it's open circles shaded to the outside. 20 is negative 1 less than n less than 1/3, and it is open circles shaded in between. 22a is the absolute value of 2.6f plus 47.2 is all less than 3. Number 22b is absolute value of h minus 177.2 is less than 3, and that one is, and 174.2 centimeters is less than h is less than 180.2 centimeters. 24 is the absolute value of x minus 1 is greater than or equal to 5. 26 is the absolute value of x minus 1 is greater than 2. 28 is the absolute value of x minus 4, is less than 6. 30 is the absolute value of x minus 5 is less than or equal to 3. 32 is the measure of angle 4 is greater than the measure of angle 1, and the measure of angle 4 is greater than the measure of angle 2. 34 is the measure of angle 5. No, I can't even talk what I'm saying. No, not the measure. M. We got this. Yay. M is greater than negative 5, or M is less than negative 12, and it's open circles shaded outside. 36 is no solution. Well, the null set technically. Nothing shaded nowhere. 38 is negative 9/4 is less than p is less than 5/4, and it's open circles shaded in between. And finally, last and certainly least, is W is less than or equal to negative 23 halves, or W is greater than or equal to 7 halves, and it's closed circle shaded on the outside. And just in case anybody is completely confused, the or doesn't mean you could write either one of those. You write that whole thing with an or in between. Hopefully we weren't totally lost on that, but it's not either or, it's you write that whole thing. Okay, what questions do we have on that lesson?
24 through 30.
Try again. What questions do we have on that lesson?
24.
Great, got you. The destructions say, write an absolute value inequality for each graph. Great. Sounds good. Where is the middle of those 2 points? Negative 3, 5, negative 2, 4, negative 1, 3, 0, 2, 1. One is the middle of that graph. How many do we have to go to get to 6? 5. We have to add 5. How many do we have to go to get to negative 4? Have to subtract 5. So it's going up 5 and down 5. There may be a couple questions still in your brain. Go ahead and ask them. That's a great question. That is one of the couple questions that makes sense. Why is it minus, right? Instead of a plus is the biggest part of that question. You might be like, why is it 1, right? 1 is because it's in the middle, right? I'm going from 1 out. So, when we solve this Dumenflachi, right, we're going to have x minus 1 is greater than or equal to 5, and x minus 1 is less than or equal to negative 5, right? To get rid of the 1, what we got to do to get rid of it? Add 1. So the 1, when we do it, the sign flips. So the sign is opposite on the inside. Okay? So that's why it's a minus 1, because it's going to be opposite. Because I will tell you that's worth writing as a little side note or locking into the back of your brain, because that idea is going to come up again multiple times. If you start to think about things as if it's in the print, if we're doing something that's got a graph happening, whether it's 2D or whether it's 1D or whether it's 2D, if you're starting with something inside parentheses, now these are not parentheses, they're absolute value, and that's why I use parentheses and air quotes. And parentheses can be parentheses, or they can be in the exponent, or they can be in the denominator, or they can be in the square root, or whatever. But in parentheses, if it's in parentheses, it's going to be opposite of a direction of something you might expect, of the direction you might expect. So that idea. So that's why the minus. So there might be another question happening in your brain right now. Is there any other question about the answer that may be in your brain right now? It might go something along the lines of, how did you know blank? Yeah, how did you know it's greater than? Because it's going this way. It's going to be greater than, numerically greater than. If it was in here, it's going to be less than. And you can test whether you are thinking right by just doing what I did and solve the little equation. And if you get what you started with, then you did it right. Otherwise, you probably did it backwards. Or you may have been totally off. Making sense? Is that the new Gen Z thing?
It's a Gen Z thing.
Is it?
Yeah.
Okay.
Spent too much time around those dirty, rotten public schoolers. My mind's been infected.
All right. What other questions from this lesson?
For problems like 34 where there's an 4 in the middle, we just do 2 problems and find the answer.
Yes. You do it this, which is the same way you do it otherwise, really, right? Even if it's written as a compound inequality, you're still doing 2 problems. You just, one part of it matches, right? But yeah, you just do it twice. Keep the or shoved in between them.
Then would you get 4 answers?
No. If it was an absolute value, this absolute value or this absolute value, then you might get 4 answers. But like on number 34, specific, let's do number 34. That may be easier way to talk through the answer to your question. M minus 7 is greater than negative 12 or negative 3m plus 2 is greater than 38. Right? So let's see what they have to say. You can actually hear me now, whoever you are. Oh, you're somebody different, unless you have multiple names. Yo, Captain. Okay. What is up? Okay. So we would add 7, right? Easy money. And over here we would subtract 2. So we'd end up with m greater than negative 5 or negative 3m greater than 36. Then we divide off the negative 3 and end up with m greater than negative 5 or m less than negative 12, right? For part of our answer. They're sending you hearts. I do 0606. Is there different? I'm assuming that that's some sort of college something or other. I don't know what you're talking about. If you want a better answer, you're going to have to ask a different question with more details. Also, hearts. Okay.
I feel so validated and loved, Internet stranger.
When we graph this, we've got negative 12 and negative 5, right? Open circle, and then greater than negative 5 or less than 12, right? So this is would use a straight edge and all the things to do it pretty, but I'm rapid firing through it to get to the point. Hey, so if this said this instead, what would the answer be?
No.
Yeah, that no solution, the null set. That you can't be both greater than negative 5 and less than negative 12. That's impossible, right? So that's why the or notation is necessary, right? Because that lets this work. But yeah, does that both answer your question and anything else I wanted to say, essentially?
It was like the whole problems. He did like all of this, and it's just out of. I didn't know it was 2 separate
Oh, yeah. Well, I thought that's what you were asking. That's what you said. I'm confused, but that's fine. Hey, why are y'all all here?
To get educated, right?
Okay, great. Any other questions from this lesson? I'd love to do 36. Oh yeah, 36. 36 has got a couple of sneaky things in it, right? 36. Negative absolute value of negative 5k. Did y'all know, this is going to lead into this question, that I did not make up ka-chink, ka-chink. It was an elementary teacher. Okay, so first potential speed bump on this problem is you might be tempted to ka-chink, ka-chink, because almost always when we got two negatives sitting right next to each other, we ka-chink, ka-chink. But I know I said earlier, we can kind of think about absolute values like they're parentheses, but not in this context. Because they are more than an absolute value. They're more than a parentheses. They do something, right? So we can't get at that negative until we dealt with the absolute value. And we can't split it into two until the absolute value is by itself. It's not by itself yet. How do we get rid of the negative? Yeah, either one of those answers are work just fine. Either multiply or divide by -1. I usually write it as a division, just because I do. Like if you want to write it as multiplication, whatever. Same difference in this particular context. We've talked about that before, actually, that multiplication and division are the same thing. Division is just dividing. I've already made a mistake because I was talking and writing at the same time.
Flip the sign.
We gotta flip the sign because we divided by a negative. Division is just dividing. That was the most that came out of my mouth. I'm gonna have to get somebody to like monitor the chat. We're gonna have to pay somebody to watch the. It's Cambridge IGCSE Add Math Syllabus Codes. The stream would assist me from my upcoming exams. Well, since I don't know what code 0606 is, if it's like a college algebra class, then yes, this could potentially help you with your stuff. If it's something else, then I don't know. If it's developmental algebra, this is probably beyond that class. Okay, now what?
Do you split into different problems?
We do.
What's a negative on the end? Is it still
Yeah, but that's not an equals. Although it's probably gonna break, but we gotta test it. Okay. When we split it into two on these, I usually do like to just write it as an equals because it's easier to think about. Because when we have these absolute value ones, we always test all of our solutions to see whether they work. Right? So we divide by -5. And we end up with k equals 3 and -3. And by equals, what that means is that those are our critical points. We're going to use this. This is a strategy that we're going to use when we get to graphing up stuff too, where we're looking for points and we look for different points and then we figure out what does the graph do around them, right? And this is only one dimensional, so does it exist is all we're checking for now. But when we get to graphing some crazy stuff where we start to graph things that look something like that or something, they're like, okay, there's a point here. What does it do here? And then we go from there, right? And so we're going to use this critical point idea many times in this class. Okay? So what we need to do is we need to check these regions. So we can with our straight edge, graph the thing, and then we plop on -3, and then we plop on a 3. And then we've got these little zones. And the way this works is if it works for any number over here, then it works for every number over here. And if it works for any number here, then it works for every number here. If it works for any number over here, it works for all of them. So you just pick up a number that's over here and you test it. So what's the number over here?
-4.
-4. Sounds great. So we're going to come back over here and plop in a -4 and see what happens. Okay, so -5 times -4. Is that greater than 15? Okay, what is -5 times -4? 20. What is the absolute value of 20? Is -20 greater than 15? No, it doesn't work over here. Great. Now let's pick a number here. What's the number we can pick here?
2.
I'll pick an easier one. There's an easier one.
1.
No, there's an even easier one. 0. Plug a 0 in there. What's the absolute value of 0? 0. What's -0? Still 0. Is 0 greater than 15? No, great. No matter what we shove in there, it's going to be negative. Is it ever going to be greater than 15? No. Great. Doesn't work here, doesn't work here. It doesn't work anywhere. Easy money. Any other questions from this lesson? Tomorrow is your exam. Well, good luck on your exam. 32, he says. If you're so then the answer, in fact, to your question of will this help you with your class? It depends on whether this is what is being covered currently for your exam. So only you can prevent forest fires. Also, only you can answer your own question. Okay, so we have a picture that looks more or less like this. Labeled A, B, and C are these points. The angles are labeled 1, 2, 3, and also 4. Then all the words say the exterior angle inequality theorem states that an exterior angle is greater than the measure of either of its corresponding remote interior angles. Write two inequalities to express the relationships among the measures of the angles of A, B, C. This is bigger than either one of these, is what that said. Right? So how do we write that? No. Angle 4. The measure of angle 4, if we want to be technical, if this was in a geometry class, I probably would have to count off for you if you didn't put the measure of angle 4, right? Because pictures are congruent and numbers are equal. Measure of angle 4 is greater than the measure of angle 2. And then it wants another one, so you do the same thing with angle 1, right?
I feel so stupid.
You don't have to feel stupid. You got this.
You write an and or?
What?
Is it like and or?
It would be like comma. Because it's not really a compound inequality. It's just write two inequalities. Honestly, I don't know that arguably this question even belongs in this lesson. Like, it's not really even a compound inequality. It's just do a thing, and we want to scare you about geometry again. It's so fun. Great. Jump scare. Jump scare. Ah! I felt like it was a proof coming for me.
Oh,
It's not real, they
32.
can't hurt you, except they are real and they can hurt you, and they do.
I think we should take a quiz. What do y'all think? Or do y'all have any other questions?
Yay, quiz! What if you don't take the quiz and say you're dead?
Then you wouldn't know whether you get it or not. And that could be sad. Because then you might do worse on the test.
That's very sad. That is a very good point.
Quiz 1-6. Oh, that reminds me. What does that say? Numbers. Are we listening? This does not say number 5. I have never written my 5s like a lazy person. That has never happened. 5s have a down and a round and a hat. So I am not going to assign you number 5. I did not assign you number 5 on the last quiz or the quiz before that.
Has this been a reoccurring problem?
Yes, for more than one human. So I figured I would briefly address it. So you don't have to waste your time. And I don't have to be like, what? Okay. Page 45. Numbers. It'd be kind of funny if I did assign 5. That would be funny. Numbers 13. I really want something different. But that's fine. Number 13 and number 19 and number 23. Ready, go. Sonic. Gas. MIT USA. Well, I hope you enjoy your time at MIT USA. This is a high school class. Although we do teach at a fairly rigorous level here. So, you know. Good luck on your exams.